So we're kind of continuing on what we've been doing. So next we're going to look at finding the trig functions of any angle. So always when we're doing this, we start at the x-axis and theta goes from that to the line where we have our point x and y. So we're always going to use the xy coordinate, and then we need to use x and y to find r, so we use this little formula here. So r is equal to the square root of x squared plus y squared. And then to find all 6 of our trig functions, we have them all here. So sine of theta is y over r, cosine theta is x over r, tan of theta is y over x, cotangent x over y, secant r over x, and cosecant r over y. So these are 6 trig functions. So all of these questions are going to give us x and y. We need to find r, and then we just plug them in. So example 1, let -3, 4 be a point on the terminal side of theta. Find the sine, cosine, and tangent of theta. So first thing we need to do is find r. So r is equal to the square root of x squared plus y squared. So we just need to plug in our x and y. So r is equal to the square root of -3 squared plus 4 squared. So r is the square root of 9 plus 16. So what's r equal to? Square root of 25, which is 5. So now we need to find the sine of theta, cosine theta, and tangent of theta. So sine, we said, is y over r. So what's our y?
4.
4. And our r, we just found, is?
5.
5. So sine of theta is 4 over 5. Do the same thing for cosine, but cosine is x over r. So what's our x? -3. And our r is 5. So cosine theta, -3 over 5. And lastly, we have our tangent of theta, which is y over x. So this would be 4 over -3. Any questions?
We're just finding those 3, Miss Carver? Not the other one?
That's all the question asked for.
Oh, yeah.
In the next examples, we'll find all 6. Alright, so determine the exact values of the 6 trig functions of each angle theta. So first thing we need to do is find r. So r is equal to the square root of x squared plus y squared. So r is equal to the square root of 4 squared, which is 16, plus 3 squared, which is 9. So what's r equal to? 5. Now we just take that and plug it in. So first let's start with sine of theta. Sine is y over r. So what would sine of theta be?
3 over 5.
Perfect. What would cosine of theta be? 4 over 5. Tangent of theta? 3 over 4. Next, let's find our cosecant. What would cosecant of theta be?
5 over 3.
5 over 3.
5 over 3. So remember, cosecants, the reciprocal of sine, so we just flipped the sign. So 5 over 3. Next, we have secant. What would secant of theta be?
5 over 4.
5 over 4. And then lastly, cotangent.
4 over 3.
4 over 3. Perfect. Any questions on this one? Alright, let's look at part B. So here our x is -8 and our y is 15. So first thing we need to do is find r. We have the square root of x squared. So -8 squared plus y squared, so 15 squared. So r is equal to the square root of 64 plus, what's 15 squared?
225.
225. 64 plus 225 is 289. So what's the square root of 289? Olivia says 17. Do we all agree? Yes. So r is 17. Now we plug everything in. So first we need to find the sine of theta. Sine is y over r. So what would our sine be? (15 over 17).
15 over 17.
What would cosine of theta be?
-8 over 17.
(8 over 17). What about tangent of theta? (15
over -8.
over -8). Then we have cosecant, which is r over y. What would cosecant be?
(17 over 15).
17 over 15. Then we have secant, which is r over x. So what would secant be? (17 over -8). And then tangent of theta is x over y. So that would be -8 over 15. Any questions?
Isn't it cotangent?
Oh, yes, you are right. Should be cotangent. My bad. Alright, so the point is on the terminal side of an angle in standard position. Determine the exact values of the 6 trig functions of the angle. So here, we're doing the same thing, but it doesn't actually give us the picture. It just gives us x and y. Do we need the picture to find the rest of it? No.
No.
We just plug in x and y into our r formula, and then plug everything into our 6 trig functions. So r is equal to -4 squared plus 7 squared. So r is the square root, 16 plus 49. 16 plus 49 is 65. How can we simplify the square root of 65? Can we?
No.
No.
Yeah.
We can?
No, we can't.
No. Because 16 breaks down, or 65 breaks down into 13 and 5. and 13 is prime, 5 is prime, so we have no pairs. So square root of 65 is as simplified as can be. So now we can just plug everything in. So first let's find our sine of theta. What would our sine be?
It would be 7 over square root of 65.
Perfect. 7 over square root 65. Can we have a square root in the denominator?
Nope.
Nope. So multiply the top and the bottom by square root 65. So we have 7 square root 65 over 65. Next, cosine of theta. What would cosine be?
Negative 4 over square root of 65.
Negative 4 over square root 65. Got to multiply the top and the bottom by square root 65. So negative 4 square root 65 over 65. Next we have tangent. Tangent is y over x. So what would our tangent of theta be? Seven over
negative 4.
negative 4. Perfect. Then cosecant.
Be square root of 65 over 7.
Awesome. Then secant.
Square root of 65 over negative 4.
Perfect. And then lastly we have cotangent.
Negative 4 over 7.
Perfect. Good job, guys. So this is pretty much just finding r, plugging it in. Remember, can't have a square root in the denominator, so you have to rationalize if you do. Any questions on this one?
Nope.
All right. Last example. What's the first thing we need to do?
Identify x and y.
So x and y. What's next?
Find r.
Find r. What's our formula for r?
R equals square root of x squared plus y squared.
Perfect. So r is equal to the square root of 3 squared plus negative 4 squared. So r is equal to square root of 9 plus 16. So we have the square root of 25, which is 5. So r is equal to 5. Now we take that and plug her in. So we have sine of theta is what?
Negative 4 over 5.
Negative 4 over 5. Cosine of theta,
3 over 5.
3 over 5. Tangent of theta,
Negative 4 over 3.
negative 4 over 3. Cosecant of theta,
5 over negative 4.
5 over negative 4. Secant,
5 over 3.
5 over 3. And cotangent,
3 over negative 4.
3 over negative 4. Awesome. Alright, so this is it for the notes today. You're not turning anything in. You don't have homework over the weekend. This will be like with part 2. I'll probably make the WebAssign and assign it, but it won't be due until Tuesday. So if you want to get a head start, it will probably be there by the end of the day today, but it won't be due until Tuesday. And it'll be like part 1 and part 2 together.